Yeah. Okay. Thank you very much. It's great to be here today. I want to thank the community of Utqiagvik for inviting me here to your home, and to UIC Science, both of you for allowing us to do our research here. Both are very much an honor. So I'm the Field Operations Manager for the National Ecological Observatory Network. We're a continental scale, long-term ecological observing platform funded by the National Science Foundation and operated by Battelle. The headquarters are in Boulder, Colorado. I'm based in Fairbanks. We've got 8 research sites in Alaska, including one here in Utqiagvik. So we work in both the Arctic and subarctic here in Alaska. On the map, you can see the blue dots and the green dots. You don't have to worry so much about the size of the dots, but the blue dots are aquatic research sites and the green dots are terrestrial research sites. Here in Utqiagvik, this is the northern endpoint for the Neon Observatory. The key point here is that all the domains of the Neon network, the 2 that we work in Alaska, being the taiga and the tundra, follow different themes. And the theme in Alaska is permafrost and understanding ecological response to changes in climate and these major permafrost habitat types, from the non-permafrost site in the south at Delta Junction up through our discontinuous sites in the interior of Alaska, and then here on the north slope, of course, continuous permafrost. So really, how do these different permafrost regimes respond to a changing climate? We are part of a national network. We have 47 terrestrial sites and 34 aquatic research sites across the US. Our closest aquatic sites to here are at Toolik Field Station. We have both a lake site and a stream site. We have 3 major, sorry, I'm gonna back up for a second. So at below the map, you can see the timeline of the observatory. And we really just finished construction a few years ago. The official transition to operations was 2019. We've been collecting data here for about 5 years. So this presentation is all about the future. We have 3 primary data collection systems. So we have our automated instrumentation. You can see our atmospheric flux tower here out on the BEO, as well as our below ground sensors, which basically build the net ecosystem exchange monitoring suite. And then we have our observational sampling, which I'll talk more about in a minute. And then our airborne remote sensing platform, which includes the hyperspectral spectrometer, LiDAR, and high resolution imagery. That plane flies all sites in the network during peak green, and we know we're in the peak green season here now. And they're in Dead Horse right now. I think they're flying Toolik Lake today. I tried to get them to fly here today because they said the weather was nice, but I guess the weather was nicer there. So this is a map of our research, our research plots out on the BEO. Well, there's several yellow dots, but sort of in the upper arm there is where the flux tower is located. We've got about 20 terrestrial plots there whose measurements are most closely linked with the tower measurements, so mostly productivity and biomass. And then you can see all of our distributed plots throughout the BEO, where we're collecting samples on a range of different key indicator taxa that we think will be indicators of change over time. And you can see the different measurements that we collect on the different taxa. Diversity and abundance is sort of a universal theme, as well as the presence of pathogens in small mammals and mosquitoes, the phenology of plants and mosquitoes, and then the productivity and biomass for the plants and soil microbes. So everything we collect is freely available. Broadly, these are the themes that our data products can be lumped into. We do not have the eco-hydrology data for our site here because this is just one of our terrestrial sites. And everything we collect are stored in one of two locations. So Arizona State University curates the Neon Biorepository. All of our specimens and samples are available to the research community to be checked out and used for your own individual research questions. And then all of our digital data products are stored on the data portal, which I have linked here. So as I said, we're very much a new observatory. We're projected to collect data here for the next 25 years. I did want to highlight just a recent study that I found using NEON data, an example of the research community using NEON data, and this is from Toolik Lake. And this is looking at the response of soil pores to freeze-thaw cycles in Alaskan permafrost soils. I think this is really interesting because when we talk about a warming climate, we think about thawing permafrost, but what will probably happen in reality is that thawing permafrost will go through cycles of freezing and thawing before it's, you know, permanently thawed. And so Erin Rooney and her colleagues looked at this by taking some of our soil cores from Toolik Field Station and subjecting them to freeze-thaw cycles. And the finding was essentially that they found decreasing pore connectivity, soil pore connectivity within the soil cores, and that could have implications for the transport of water and its availability to plants, for example. And I thought, after listening to Donatella's talk this morning, you know, there's some interesting questions there. Does that change carbon respiration or methane release? Just a lot of interesting ideas. So in addition to the ecological observations that we collect and make available to the research community, we have another program called the Assignable Asset Program. This has been particularly popular in Alaska at all of our sites. Broadly, I think they fall into these three categories. So site access and research, or site access coordination. You can see in the upper left-hand corner, that's Dr. Laura Prue working on the above project in our Healy Flux Tower in the background. Her study was on wildlife movements in winter landscapes in the Alaska Range. And she's digging a snow pit near our Met station because her presumably the data from our tower will be used to inform her own research questions. And then in the middle, you can see Dr. Craig Tweedy on our tower here in Utqiagvik with one of our tower technicians. We just put one of his SIF instruments on the tower top. And the access to the sensor infrastructure, in particularly Alaska, because we have the climate controlled hut in addition to the tower, and the sites all have power and they're all networked, so you can essentially monitor your own data streams through the infrastructure. And if you don't like where our tower is located, we can build you your own, as we did for Dr. Watts at our site in the Caribou Poker Creek's research watershed. And lastly, we also do sample collection for PI. So a couple of images there on the far right of us collecting various terrestrial and aquatic samples as part of continental scale biodiversity studies. So I want to talk a bit, this is probably the most important slide that I have. Our partnership with UIC has been really instrumental in keeping our operations running up here. Shout out to Martin and his team. They've taken a leading role in essentially working on our tower and maintaining our data. The pandemic, we had a really strong training program in place where we were up pretty regularly training as teams on essentially sensor and instrumentation maintenance. And we hope to pick that up again, but through the pandemic, they were able to ensure that the data was continually from the tower. And then just this year, we extended that program through an internship, bringing on a student from Illisovic College as a U.S. intern. I'm on the NEON program, terrestrial vegetation sampling out on the BPO. The goal, of course, with this partnership of UIC is, I think UIC's in a really strong position to not only to promote their scientific capabilities, but to leverage their position to bring researchers together and advance Arctic research. So this is just a graph of publications using NEON data over the last several years. I think this is really interesting. 2019. And we saw a big spike in publication, NEON data. So we hope this trend persists. But I do think the power of the observatory and our data is really beginning to be realized. And I was excited to see the NSF's recent announcement of the environmental data science center will be to combine and synthesize large-scale network data sets. So I think NEON is really positioned well to be at the forefront of understanding global change. Thank you.